All right, test, test, test. Hopefully the sound works here. I see it moving. I think I fixed the problem, so I'm gonna remake these videos. So the only one that should have been muted is the factoring difference of perfect squares and all that. Okay, but it's still watchable without the sound, but I'm gonna remake the rest of the videos. All right, so today we're factoring polynomials and we're factoring by grouping. These are the steps. Group the first two terms together and the last two terms. All right, then, so we're looking at number one on this side. All right, so we're gonna group those together. Don't forget this negative with the -4. All right, then it says factor the greatest common factor for each group. So we see with x cubed and x squared, the greatest common factor, which means the highest thing, highest term, both terms can be divided by, is x squared. So we put x squared on the outside, and then we divide each of them by the greatest common factor to see what is left. That should be easy. That should be second habit now, okay? Second nature. Then we're moving on. We see over here we have -4x minus 4. The greatest common factor between those two is -4. And then inside we have x plus 1. If you notice something, the inside binomial is the same. We have to have the same binomial, okay, on the inside. So if I factor out x squared and I'm left with x plus 1, and I do that one first, I know on the other side it should be x plus 1, and then I can just figure out how do I get it there and what do I move outside, okay? Then it says step 3, factor the common binomial. Okay, so if you need to, this step 3 sometimes is needed. It isn't always a step, but if you see x plus 1 is coming here, and then we see what's on the outside, x squared minus 4 becomes a binomial. We combine those, and then we bring it down here. But then we notice x squared minus 4 is a perfect square. It's a difference of square, which is a perfect opportunity to teach with sound. I can teach you difference of squares real quick. Okay, so x squared, I'm going to stop factor by grouping just to show you how to do difference of two squares. X squared minus 4, we know we're finding the difference of two squares. You know to use difference of two squares when both terms can be square rooted. The square root of x squared is just x. You have to trust me on that. Square root, this is a square root symbol of x squared. It's like this and this cancels out. I've said that before. So the square root of x squared is just x. It's always just x. So if you ever just see x squared, you know it's going to be x and then x. And the way we write it, it was on the notes yesterday. One is going to be x plus something and x minus something. All right? So this would be our a, and 4 would be our b. But the way we figure that out is we square root it. So we're going to square root the entire term. The square root of x squared is x. So a is x. The square root of 4 is 2. Then, according to those notes yesterday, the answer is just a plus b times a minus b. So we found a, we found b. So a is x, x plus, and then b is 2, and then x minus 2. They're always going to be similar. It should always be a plus b times a minus b. So basically, when there's no greatest common factor, we have x squared minus 4. Step 1, just square root the whole thing. Just do one term at a time. Square root, and this is how we find our a, and this is how we find our b. The square root of x squared is just x. The square root of 4 is 2. Then I just plug it into the equation. The equation was a plus b times a minus b. All right? So it ends up being x plus 2 and x minus 2. And one has to be plus and one has to be minus, okay? So hopefully that helps now that we have sound for difference of squares. So let's get back to grouping. So again, if we ever have a perfect square, we're not done here. we're going to factor it out, which I just showed you was x plus 2, x minus 2 times the other binomial. So we start here, we grouped the first two and the last two together, then we factored out the GCF of this one and this one. The highest, the biggest thing to be combined by is x squared, and then the GCF over here is -4. The x squared and the -4 combine to be a new binomial that moves down here, and then the x plus 1, we notice the x plus 1 is the same here and here. So we move that down. Then, if needed, we will factor this common binomial, only if it's a difference of perfect squares, okay? So let's do some examples together. I might have confused you, but I promise you it's not that bad, okay? So looking at number 1, we're going to factor by grouping, so I'll put that together, and that's a positive 9x minus 9. So we're going to factor out the GCF. Well, we just saw in the example it was x cubed minus x squared, and we know the GCF is x squared, and then what is left? X minus 1. Alright? Then we know over here it needs to be x minus 1, because these need to match. So then from there, let's just see what is on the outside. What is the greatest common factor? How do we get from 9x minus 9 to x minus 1? Because we know it needs to be that. Well, we know we're taking out the number 9, a positive 9. So let's combine this and this one. We have x squared plus 9. Notice it's not a minus. That's crucial. I'm about to tell you why. And then x minus 1. And that is our final answer. We actually cannot simplify anymore. That's why it was crucial to know that this was positive 9. If that was a negative 9, we would have had x squared minus 9, and that would have been a difference of perfect squares. Then we could have factored out and did x minus 3, x plus 3, and that would have been factored out. But because it is x plus 9, we cannot simplify it anymore. So that is our final answer. Okay, not that bad. Remember, if you ever get a difference of perfect squares, then you can factor that out a little bit more. But if it's x squared plus 9, you can't do anything else. Okay, moving on. Here we go, and that's a negative x minus 5. So again, we see that the greatest common factor for the first one is x squared. What is left? We have x plus 5. So then we know over here it has to be x plus 5 on the inside. What can we put on the outside? Well, all we did was just flip the sign. See how it's still an x and still a 5, but instead of negatives, they're now positive. So what do we put on the outside? -1. You just need to know that, because think about it. -1 times x is negative x, and -1 times 5 is negative 5. So the greatest common factor between negative x and negative 5 is just -1. So now we have that problem I told you about, where now it is x squared minus 1. That is a difference of perfect squares. So again, if you practiced enough the other day, you know it's just x plus 1 and x minus 1. There's no trick or trade to it, okay? The square root of x squared is x. The square root of 1 is 1. So then we know the answer is a plus b and a minus b. So x plus 1, x minus 1. So our final answer, when factored out, is x plus 1, x minus 1, and then, of course, the common binomial x plus 5. And we are done. All right. We'll do one more together. I'll do number 4, because they're kind of big numbers, so I want to show you that. So again, group them together. Group them together. This time, if we look, we have x to the 4th plus 5x cubed. So the greatest common factor here is actually x cubed. Okay, don't just assume it's always x squared. So x cubed, and what is left? We have x plus 5, right? That's for the first part. Then we know on the other side, x plus 5, plus 5, needs to be on the inside because those have to match. So let's just look. What is left on the outside that we need to put out there? Okay, well, we see they were both negative, but inside they're positive, so we know it's a negative. Then we see x is left over. Instead of 4, we went from -4 to a positive x, so the 4 goes there. And then we're missing an x here, so -4x. That's just kind of the kiddie way to figure it out, but if you had just found the GCF, you know the GCF between -4x squared and -20x is -4x. Then you would divide both by -4x, and you're left over with x plus 5. So let's combine those. We know the first one is x cubed minus 4x. All right. And then the second part is x plus 5. Okay. Watch this. There's a greatest common factor here between these two. All right. It's going to be x. Let me write it over here. X is the greatest common factor, and we're left with x squared minus 4. When we look at that, we see that is a difference of perfect squares, so we're going to factor it out. So x, the greatest common factor, is on the outside, and then x plus 2, x minus 2. Again, we just need to know that by now. And then finally bring the x plus 5 down, because that was the common binomial. It shouldn't be too bad. If that part was confusing, you can go back, you can watch it, but don't panic. Okay, all I did was, number 4, I had x cubed was the greatest common factor, and what was left over? X to the 4th divided by x to the 3rd is x. 5x to the 3rd divided by x to the 3rd, you're left with 5. So we know the common binomial is going to be x plus 5, so we know it's coming over here as well, and then just figure out what did we take from here to get to x plus 5, which is a -4x. So one of our binomials is x cubed minus 4x, as we're combining the two outside ones. And then inside is x plus 5. Then from here, we see x cubed minus 4x. There is a greatest common factor. What is the greatest common factor? X. When we move x out, we see x squared minus 4. That's a perfect square. Difference of perfect squares. So then we factor that out, and our final, most simplified answer is right here. Not always will the problems be like that. Okay? Usually they're as simple as number 1 and 2. Alright, so complete the worksheet. I'm going to test to make sure this had sound. If not, I just wasted my time again. But I think it has sound, so we're good.